Okay, here is the independent practice, page 285. I asked her to do 1 through 13, only the odd problems. Here are the answers, just in case you want to know how you did. Number 1 is 1 and 1/6. Number 3 is 2 and 27 over 32. Number 5 is 9. Number 7 is 9 and 1/4. Number 9 is 3 and 3/8 of a cup. And number 11, there's actually 4 answers. Okay, so bear with me here. Letter A is 69 and 27 over 40 million miles. Letter B is 139 and 720 million miles. And letter C, 487, 29 over 40 million miles. And letter D, 802, 11 over 20 million miles. And the last one, 13, is 1 and 124. I keep emphasizing the and because I want you to remember that you're really adding two things for mixed numbers. You're combining a whole number with a fraction, okay? That makes a difference. I hope you understand that. All right, so let's get started. All right, number 1, we have 1/2 times 2 and 1/3. At this point, you should change mixed numbers to improper fractions. Okay, it's just easier to multiply it that way. I mean, you saw what I did in previous problems. You can still multiply the 1/2 times a 2 and then the 1/2 times a 3. It's just more work. It's easier to change this to an improper fraction. Okay, so anyways, 1/2. We're making groups of 3. The denominator stays the same because that's what we're making. So, but we have two groups of 3. So that's 3 times 2. And we're adding 1 to the mix. All right. 1/2 times 3 times 2 is 6 plus 1 is 7. 7 over 3. Okay, and at this point, numerator times numerator, denominator times denominator. All right. You have an improper fraction. The value is the same as a mixed number, but what's wrong about it is that it, as a fraction, is supposed to be less than 1. When it's improper, it's actually showing more than 1, and that's not what a fraction is supposed to be. So there we go. All right. You're making groups of 6. You should be able to see that you can make at least one group out of 7 with 1 left over, and remainder, sorry, the denominator stays the same. You're still making sets of 6. All right. 1 and 1/6. All right. Letter 3. Oh, you know what? If you want to verify, this is a division problem. You can go ahead and divide it yourself and prove that I'm right or wrong if you don't believe me. I'm okay with that because I do make mistakes. If you feel you're right, bring it up in class tomorrow and we'll go over it. All right, same thing. Just get to it. Just do it. Sometimes you don't even have to think about it. Just do it. We're making sets of 4. The denominator stays the same. We're making 3 sets of 4. That's 4 times 3 plus 1. Now, if you don't understand why this works, please look at the other problems that I've done in the beginning with the got its and the guided practice. I did show you visuals of how this actually works. Okay? But let's get to it. 7 over 8 times, and then 4 times 3 is 12, plus 1 is 13, and it's still over 4. All right, one thing I didn't do with the other problem, I'm going to do now. I'm going to check to see if I can simplify. Nope, I cannot. So just go ahead and do what you got. Denominator times denominator, that's 32. Numerator times numerator, that's 13 times 7. I'm going to do it over here. 91. Okay. Again, another improper fraction. You have to change it to a mixed number. Do not leave it as an improper fraction on the quiz. I will mark it wrong. Okay. I'm making groups of 32 out of 91. I could try 3 groups. It's about 30. 3 groups of 30 would be 90. But don't forget that extra 2. That would be plus 6. It would be 96. Too much. Okay? So let's try 2. By the way, if you want to try 3, go ahead. It's okay to make mistakes, people. It's okay to make mistakes. 2 times 3 is 6. You subtract. Okay. You need to break open this 9. Regroup. You break away a 10. You're left with 8 10s, which is 80. And that one group of 10 is right here. 10 plus 1, 11. 11 minus 4 is 7. 8 minus 6 is 2. So the answer is 2 with 27 left over out of 32. Let me just do a quick check. They're both not even, so I can't divide by 2. 7 plus 2 is 9. 3 plus 2 is 5. They're not multiples of 3. Let's see, I can't use 5 because they don't end in 5 or 0. I can't use 10. I'm going to assume that these are, they don't have a common factor, so I'm going to leave it at that. All right, number 5. Okay. 3 3/4 times 2 and 2/5. Okay. With the other problems, you've seen me estimate first to make sure. Okay, when you have mixed numbers like this, you know what? There's no harm in just looking at the big numbers. The whole numbers, excuse me. I have a 3 and a 2. That's my answer is going to be around 6, maybe more, maybe less. Well, actually, it's definitely going to be more because you're also adding the 3/4 and the 2/5. Okay, you also have to include that. Okay, but at least I have an idea. Okay, if you really want to get into it, 3 plus 3/4 is pretty close to 1. That would be 4. 2 2/5. 2/5 is close to 0. That would just be 2. If you've seen what I did before, this will make sense what I'm saying. So it'll be 4 times 2, 8. So it's 6 or 8. But again, let's just do the math. 4 times 3 is 12, plus 3 is 15 over 4. 5 times 2 is 10, plus 2 is 12. Okay. Ooh, okay, now see, I'm going to look. I'm going to see if I can simplify before I multiply. I mean, I could multiply this. 15 times 12 is easy enough. 4 times 5 is 20. But I'm going to see if I can make the numbers a little smaller. So I'm going to do like a little butterfly thingy. 5 and 15 have a common factor of 5. Remember, in the other lesson I showed you why this works, okay? So if you don't know how I did this, look at lesson 3 and 2 and see what happened. 12 and 4 have a common factor of 4. Okay? So 15 divided by 5 is 3. 4 divided by 1. 12 divided by 4 is 3. 5 divided by 5 is 1. See? Much easier. 3 times 3 is 9. 1 times 1 is 1. And I'm making 9 groups of 1. That's the answer then is 9. By the way, if what I did here simplifying before I multiply doesn't make sense to you, that's okay. You can still multiply numerator times numerator, denominator times denominator. You're going to get an improper fraction. Do the division and see what you get. But I guarantee you're going to have to simplify that fraction at the end. You're going to have the whole number. Well, actually, if you did it right, you're just going to have the whole number. There's no fraction. The point is, you can simplify first or simplify at the end. Okay? All right, under number 7. Ooh, number 7 is a word problem. Okay, I like drawing them out. A carp can travel at a speed of 3 7/10 of a mile per hour. At this rate, how far can a carp travel in 2.5 hours? Okay, if you read it quickly, you'll think carp is a car. A carp, if I know this, if I should, I remember it being a fish. Okay. And again, there's no harm in looking up at the internet to see if, just to verify. Okay. Do that. If you get to a word problem, or when you get to word problems and you see words you don't understand, look it up. There's no shame in looking it up. But a carp is a fish. All right. So it travels. It's saying that a carp travels 3 7/10 of a mile for every 1 hour. It's like a ratio. And actually, it's not like a ratio. It is a ratio. For every hour, it goes this far. You're comparing distance with time. All right. So the question is asking, how far does it travel in 2.5 hours? Okay, so it's another hour. And then half an hour. So it's, hopefully you can see that it'll be this plus half of that. Right? But anyways, let's do the math first, because in here we have 1 hour plus 1 hour is 2 hours plus half hour, 2.5 hours, right? Okay. So we have 3 7/10 times 2.5. Okay. Now, you know what? You could add these two and take care of the 2 hours, right? This plus this, 2 hours. But then, like I said, you'd have to do this part right here, and whatever you get here, you'll add it to this. It's this plus this plus this. Again, multiplication is just repeated addition. So if you don't want to multiply, you can try adding it later on. You just have to multiply a little bit, but this should make more sense to you. You're going to draw, if you want to draw 3 7/10, 3 full boxes, and then another one that's 7/10 full, and you're going to just split it down the middle, half. That's all you want of this. Okay? But for sake of argument, let's just do the math. Okay? I'm going to go kind of fast here. Again, I'm looking at like a C. Multiplication, addition. Multiplication, addition. 10 times 3 plus 7. And the denominator is going to be 10 because we're making sets of 10. 2 times 7 plus 1 over 2. Okay. I'm going kind of fast. I realize that. And that's okay. But let's review. We're making sets of 10. That'll be the denominator. Sets of 2. That'll be the denominator. We're making 3 full sets of 10. And you see me draw this before, so you know it's going to be 30. Plus the 7 extra pieces, 37. 2 full sets of 2. 2 full sets of 2 plus 1 is 5. Oh, excuse me. How did I get... Oh my goodness. Somehow I thought... See what happens when you write incorrectly? It's 2 times 2, not 7. And if I make that correction, what happens? This, of course, changes as well. So 2 times 2, 2 times 2 is 4, plus 1 is 5. Like I said, we all make mistakes. All right, before I multiply, I'm going to see if I can simplify first. Nope, that's not an even number, but this is. And 2 is prime, so I can't make it any smaller than that. 5 and 10. I know they have a common factor of 5. Okay. 37 over 2 times 1 over 2. That'll be 37 over 4. All right, so we're making sets of 4. Sets of 4. We have 37 pieces. And you know a fraction is another way to show division. So this would be the dividend, 37. The 4 would be the divisor. How many groups of 4 can I make out of 37? I know I can make at least 9, right? If I do that, I can take care of 36 pieces, with one left over. So I can make 9 groups of 4 with 1 left over. So it's going to be 9 with 1 left over. That would be the numerator, right? The part you have, which 4 being the set, part to whole, part to whole. Don't ever forget that, part to whole. All right, number 9. A waffle recipe calls for 2 1/4 cups of flour. If Chun wants to make, could be Chun, I'm sorry if I'm saying it wrong. If Chun wants to make 1.5 times that recipe, how much flour does he need? Okay. Again, I don't need to do this. I think I visualized the problem well enough. Ooh, does that look like a waffle? The word waffle. All right, we have a waffle. Okay, so to make waffles, I need 2 cups of flour. Now wait, I know what you're going to say. 2 and 1/4 cup of flour. Oh, you can't see what I did. All right, so here's my waffle. Ugh, well, best I can. To make that waffle, I need 2 1/4 cups of flour. I went ahead and drew it as the whole number and the fraction separately, because really you are adding them. 2 1/4 is 2 and 1/4. 2 cups of flour, 1/4 cup of flour. All right, so that's just for one recipe. Now apparently this guy Chun wants to make one recipe and then half of this. Okay, so times 1 and a half. Okay, so I'm going to go ahead and rewrite it the way it might make more sense to you. 2 1/4 cups of flour times, I want 1 full recipe and half of it again. So 1 full recipe and then half. Okay, changing both to improper fractions. I'm making groups of 4. I'm making groups of 2, so that's the denominators right there. 4 times 2, I will have 2 full sets of 4, so 4 times 2 is, and then 1 piece. 2 times 1, because I'm making 1 full set of 2, plus 1. Order of operations, first. 9 over 4 times 3 over 2. Ooh, just missed it. I mean, I got excited there because I thought, hey, if this was up here and this was on the bottom, I could have simplified it. But as it is, nothing in common. I can't simplify it. So I'm going to go ahead and just multiply it out. Numerator times numerator, denominator times denominator. All right, I'm making groups of 8 from 27. Guys, I realize some of you can just do this in your head. Oh, I know it's going to be 24. That's going to be 3. 8 times 3 is 24. 27 minus 24 is 3. If you can do it in your head, hey, more power to you. But I'm going to show you the work anyways, okay? I'm making groups of 8 out of 27. 8 times 3 is 24. 7 minus 4 is 3. Again, just a quick reminder. This becomes the numerator. It's what's left over. This is what you're trying to make. You're making full sets of 8, so it stays the denominator. Okay? Oh, and I am forgetting something. This is a word problem, so don't forget to write the word, and it's just one simple word, cups. Not cup, cups. It's more than one. Okay? Little English issue there. All right, number 11. You know what? I'm going to do number 13 first, because that's real easy to do. Number 11 is more complex. So let's do 13 first, and I'll get to 11 in just a moment. All right, number 13. It says multiply, write in simplest form. Oh, all right. No biggie. It's 1/7 times 5 and 5/6 times 1 and 1/4. Guys, it's 3 factors. It can still be okay. Now, I'm just gonna make a real quick prediction. 1/7 is close to 0. 5 and 5/6. Well, 5/6 is pretty close to 1. And then 1, okay. 1/4 is pretty close to 0. I'm going to leave it like that. So it's really 0 times 6 times 0. Okay, now. The estimate's going to be... Alright, according to me, my estimate's going to be 0. Now you know the answer's not going to be 0, okay? But this does tell me that the answer is not going to be that big, okay? Now you're looking, but wait. Here we have a 1, a 5, and a 1. If I just look at the whole numbers, I'm thinking, hey, it's going to be around 5. Maybe. So it's going to be more than 0, but less than 5. But here's the thing. This is what bothers me. I have 1 times 5, which is 5. Then I'm multiplying it by this fraction, which is less than 1. And actually, it's pretty close to 0. So I want a small chunk of this 5. I'm thinking it's going to be close to maybe 2. But hey, again, we're just estimating. I just want you to have an idea that the answer is not going to be more than 6. Or more than 5 even, okay? So if you put 10, you know you did something wrong. Anyways, let's get to work. 1/7 stays the same. We're making sets of 6. The denominator stays the same. And again, 6 times 5 plus 5. 4 times 1 plus 1. And we're making sets of 4, so denominator is 4. 6 times 5 is 30 plus 5 is 35 over 6. 4 times 1 is 4 plus 1 is 5 over 4. Yeesh. All right. I'm going to see if I can simplify first. Yes. 7 and 35 have a common factor of 7. Guys, like I said, if this summer, please work on your times tables. Or if it's not summer yet, any free time you have, please work on your times tables. So that'd be 1 over 1 times 5 over 6 times 5 over 4. 5 times 5 is 25. Times 1 is 1. Sorry, 5 times 5 times 1 is 25. 4 times 6 is 24. Times 1 is 24. All right, look. It's an improper fraction. This means I have more than 1. I'm making sets of 24. I have 25. I have enough for at least one full set. I'm going to have 1 left over out of 24. And that is the answer. So look at our prediction. Yeah, I said it was close to 2. It's closer to 1, but that's okay. But my answer was reasonable for what I guessed it would be to be. All right, now let's go over 11. Okay, it's not 11 was hard. The process is the same, but it is a lot of work. So you have to use this table that's right here in front of you. All right. Earth is about 92 9/10 of a million miles from the sun, right? Use the table below. How far is Venus from the sun? How far is Mars from the sun? How far is Jupiter from the sun? So all of them. Distance from the sun. All right. But we need to use this table apparently. So we have Venus, Mars, Jupiter, Saturn. All right. Approximate number of times as far from the sun as Earth. Oof, okay. This is one of those things you need to visualize it first. Okay? Or, because here's the thing, I figure most of you might just do this. You're going to see, oh, I know I have to use that. That's great. And I'm going to have to use that. And realistically, yeah. You're just going to multiply this times that. This times that. Do 4 times. Venus, you have to multiply this times that. Mars, this times that. And you could just attack it. You could. But you know me by now. I want you to understand why you're doing what you're doing. Okay, so just a real quick science lesson here. And I'm not an artist. Pretend this is space. We're outside in outer space. Here's the sun. All right. And the Earth. Obviously, it's not to scale. The Earth. There's the Earth. Okay. From here to here, it is 92 9/10 million miles. Okay? I put million. Yeah, that makes a lot of sense. Million miles. Okay. Fair enough. Venus, it says it is 3/4 of the way. And actually, it's kind of true. If you think about it, it'd be the sun, then Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. I would say Pluto. Pluto's a dwarf planet now, so it's not really a planet. But anyways, the thing here is, here's Venus, a little small thing, and it's 3/4 of the way. So it's saying, from the sun to Venus, it's not this. It's 3/4 of this. If you were to break this into 4 parts, you'd only want 3 parts of it. Okay? So that's what the math is doing. When you're doing 92 9/10 times 3/4. This is saying you don't want all this distance. You don't want that. Okay? You don't want all this distance. You only want 3/4 of it. Okay? So the process is the same. Change mixed numbers to improper fractions. 10 times 92 plus 9 over 10. Okay, 10 times 92 is 920 plus 9. Yeesh, okay. I don't like big numbers, guys. I have to admit, I'm a little lazy sometimes. But you know what? You power on through. You power on through. Okay. Nope. I can't simplify this. So here we go. Let's do the work. 10 times 4 is 40. I did the easy one first. Yay me. 929 times 3. 3 times 9 is 27. Carry the 2. 3 times 2 is 6. Plus 2 is 8. 3 times 9 is 27. All right, now we have an improper fraction. We have to change this to a mixed number. How many groups of 40 can we make out of 2,087? 2,787, excuse me. All right, let's break this apart. Can I make groups of 40 from 2? No. I'll put a little 0 there. Can I make groups of 40 from 27? No. Can I make groups of 40 from 278? Yes. My first digit will go above the 8. Now, how many groups of 40 can I make out of this? Well, it's 40. I know 4 times 5 gives me 20. 6 times 4 gives me 24. Right? And there's... I'm going to try 6. 6 times 0, 0. 6 times 4, 24. Okay. 8 minus 0 is 8. 7 minus 4 is 3. I have 38 left over. I don't have enough for a full set, so 6 is good. I bring down the 7. Okay. Oof. You know what? With what I did earlier, someone will be, how do you get that? Look at the first. It's 4, right? How many groups of 4 can I make from 3? None. How many groups of 4 can I make from 38? You have no times tables. It's going to be 9. And if I'm wrong, I can always erase it. Not a big deal. Let's get another pencil that's sharper. All right. 9 times 0 is 0. 9 times 4 is 36. 7 minus 0 is 7. 8 minus 6 is 2. Oof. All right. So I can make 69 groups of 40 with 27 left over, but I'm still making sets of 40. And there's the answer for letter A. Oh, what did I forget? Context. I need to know what I'm talking about. Million miles. All right. I'm going to do B, C, and D, hopefully a little faster. All right. I'm not going to make the drawing because at this point you should understand what's going on, I hope. Now, you're all going to start the same. 92, 9/10. Now we're going to do Mars. It's 1 1/2 times. Okay. I'm doing that because I'm thinking, okay, 92 and 1, the answer is going to be about 92 millions? Or is it? This is pretty close to 1. So it's going to be about 93, right? 93 times 1 is 93, plus half of 93, which is about 45, 130 something, okay? Again, I'm just predicting, just so I know what's going on. Now here's the thing, here's the beautiful part of this. This, we already did it. I'm just going to look back, and is it cheating? No, because I already did the work. It's 929 over 10. Okay, and this is easy. 2 times 1 is 2, plus 1 is 3 over 2. I can't simplify. Ugh. All right, 10 times 2 is 20. You know, I'm going to do the easy one first. 929 times 3. Now, I could pull out a calculator, but by the time I find it and bring it down here, or just whip out my phone, it's just easier if I do it on paper and pencil. 3 times 9 is 27. 3 times 2 is 2. 6. Plus 2 is 8. 3 times 9 is 27. And you know what I'm going to do next. It's a division problem. I can make one group of 20 from 27. Ooh, so close. If it was 80, you could have used 4, but it's only 78, so I'm going to have to use 3. 3 times 20 is 60. If I'm going kind of fast, I am. It's not just you. All right. Look at the first digit. I'm making groups of 2. Can I make groups of 2 from 1? No. But what about 18? Yes. I can make 9 groups of 2 from 18. 9 times 0, 9 times 2, 18. Now, the beauty about doing fractions is it's right there. I just need a remainder. If it was a decimal number, I'd have to put a decimal point in a 0 and keep adding zeros till I get nothing left, or stop after a certain point. It's just more annoying. I'll be honest. At this point, I prefer using fractions. 139 with 7 left over out of 20. Million miles. Okay. And letter C. By the way, at this point, if you don't want to see the rest of the video because you get it now, you can stop. You know what the answers are. Just try it on your own if you haven't done so already. If you did do it, look what you did. What am I doing differently? Okay. Jupiter. Jupiter is 5 1/4 away from the sun. So Jupiter is 5 times away. If you compare the distance of Earth to the sun, Jupiter is 5 times as far away from the sun as Earth is, plus a little more. So the number's going to be way bigger than this, right? Because this is only 1 1/2. Okay. But again, let's do this. 5 times 4 is 20. I know I said 5 times 4. We really should have said 4 times 5, but apparently my math doesn't work. It's 21 over 4, because 4 times 5 is 20, plus 1, 21. Can I simplify this? No. Oh, shoot. It's just going to get uglier and uglier. I mean, don't get me wrong, math is beautiful, but sometimes you're just not in the mood for it. Okay? And it's hot. Right now, I'm in my garage. It's kind of hot in here. So, what can I do? All right, 2 times 9 is 18. 2 times 2 is 4, plus 1 is 5. 2 times 9 is 18. Add all that business together. 8 plus 2 is 10. 9 plus 1 is 10, plus 5 is 15. Carry the 1, that's a 9. That's poosh. 19,509. Ay, Dios mío. You know what we're going to do next, right? All right. Let's get a sharp pencil. Whew, let's break this down. Where do we put that first digit? That makes all the difference. I'm making groups of 40. Can I do it from the 1? No. Can I do it with 19? No. But I can do it with 195. All right. Let's look at the first digit. How many groups of 4 can I make from 1? None. What about 19? Yes. 4. 4 times 0. 4 times 4 is 16. Boom. 35 left over. I don't have enough for another, so I'm good with 4. Bring down the 0. All right, same thing. Look at the first digit. How many groups of 4 can I make from 30? From 3? None. What about 35? I'm going to say 8, because 4 times 8 is 32. 8 times 4, sorry, 8 times 0 is 0. 8 times 4 is 32. And bring down the 9. We're almost there, guys. We're almost there. Whew. Yes, I can make 7 groups of 4 out of 30. 7 times 0, 7 times 4. I should have gone right to left, but properly. I got lucky that it didn't really matter. And actually, whoa, yes it does. 0 minus 8, like where did I get the 2? You might know, where did I get the 2 from? In my head, I did this already. But, so let me show you where I got that 2 from. Okay? So, let me, hold on. What I'm doing is going to adjust it just a little bit. Whoa, too far in. There you go. 29. So 487 with 29 left over out of 40 million miles. All right, guys, last one. Letter D. I know, you're probably tired. That's okay. Last one. Like I said, if you get it, you can stop right here. But if you want to get that A, you might want to keep going. Okay? How far is Saturn from the Sun? Okay. Yes, I'm looking what I did before. 929 over 10 times 9.5. Ooh, I like the half. That might make things easy. All right, so this is saying Saturn is 9 times away, further away from the Sun as Earth is, okay? So you take the Earth distance and you multiply it 9 times, okay? But let's get to it. 929 over 20. 2 times 9 is 18, plus 1 is 19 over 2. Nope. 29 times 19. I'm laughing because sometimes I'm just lazy. I'll be honest. I'm not going to lie to you. So I can understand how you guys feel. But I'm doing it. So do it anyways. 9 times 9 is 81. Carry the 8. 9 times 2 is 18. Plus 8 is 26. 9 times 9 is 81. Plus 2 is 83. Oof. Done with the ones place. Put a little place value there. That lets me know I'm done with the ones place. Tens place. 1 times 9. 1 times 2. 1 times 9. Add that all together. 1 plus 0. 6 plus 9 is 15. 3 plus 2 is 5. Plus 1 is 6. 9 plus 8 is 17. Oof. So we have 17,651. Over 2. Oh, Dios mío. All right, you know we're making sets of 2 out of this. How many can we make? All right. I can make 8 groups of 2 out of 17. It's not so bad, I guess. It's just 2s. Everyone knows they're 2s. Bring down the 5. Bring down the 1. Guys, if you're still, again, I'm assuming we have all kinds of people in my classroom. If you still don't know your division or your times tables, please look it up on YouTube, how to divide, how to multiply, and what your times tables are. I'm not judging you, but for next year, you will need to know this, okay? If you're using a times table chart at this moment, that's fine. But it does help to memorizing it. What am I saying? It does help if you memorize your times tables, okay? So, yeah, hold on. I think I did something wrong. What did I do wrong? This does not make sense to me. I did something wrong here. Alright, final one. We have 92 and 9/10 times 9.5. Alright, before I do the math, let's see, make sure I understand the idea. The 9.5, this is for the planet Saturn. This is saying the distance from the Sun to Saturn is 9.5 times larger than the distance that the Earth is from the Sun, okay? So our number is going to be way more than this. It's going to be 92 times this, right? So again, if you forget how to multiply fractions, you can always multiply the whole numbers and go from there. Although this would be actually closer to 93 because it's close to 1. All right. 929 over 10, you already know why I did that. Look at the other problems. 19 over 2. 2 times 9 is 18. Plus 1, 19. Okay. So I'm going to zoom in just a little if I can. There you go. All right. Okay, guys. In order to save time, I'm just going to go ahead and do the math. I used a calculator previously before I started this whole problem, just to save time, okay? But believe me, if you don't believe me, use a calculator. 929 times 19 is 17,651. Yes, I skipped a step, okay? But I'll show you the division. The division is what you guys really need more help with anyways. Okay. Let's break this down. Let's look at the big picture first. We're making groups of 20. The first mistake somebody will make is not knowing where to put the whole number, right? Do I start here and then go down the line? Do I put it here and go down the line? Where you put it determines the rest of the answer, okay? So it's kind of important. So in my head, this is what I'm doing. Can I make groups of 20 from 1? No. Can I make groups of 20 from 17? No. I can make groups of 20 from this. How many can I make out of that? That's the question. Okay, so I look at the big picture. Now let's look at the fine-tune the small picture. Can I make groups of 2 from 1? No. Can I make groups of 2 from 17? Yes. I can make 8 groups of 2 out of 17. 8 times 0, 8 times 2 is 16. Okay. Once you get this first digit in the right place, everything else should just flow. Okay. So you don't have to say, I'm lost, I don't know where to go now. Step by step. The key thing though is to be neat and organized, okay? Bring down the 5. 865 left over. That means I know I have enough for 8 at least because I did before. Alright, 51. I can make 2 groups of 20 out of 51. Gives me 40. I'm left with 11. So 802 holes with 1120 of a mile. And again, it's million miles. And that's how you do letter D.